So let's have a look at an area question from the 2014 Leaving Cert Ordinary Level Paper 2. It's question 5 and it's a question about the area of squares, sectors and triangles. So we're given a sketch of a square ABCD and we're told that the area of the square is 81. We want to find the length of the side AD. So the area of a square can be found by multiplying the two sides together, or in other words the area is equal to the length squared. Now this isn't a formula that's in your tables and so it has to be learnt. So we're going to let the formula for the area, L squared, equal the area, 81, and solve for L. So if L squared is equal to 81, well then L is the square root of 81, which is 9 centimeters. B part 1 of the question asks us to find the area of the sector of a circle that's shaded here in the diagram. So the formula for the area of a sector is pi r squared, the formula for the area of a circle, times theta over 360, where theta is the angle in our sector. Now we can see that the radius of this sector is equal to the side length of the square, 9 centimeters, and that the angle of the sector is 90 degrees. So subbing these into our formula, we get that the area is equal to pi times 9 squared times 90 over 360, which we can round off to one decimal place as 63.6 centimeters squared. So we can see that what the formula does is it multiplies the area of a circle by the fraction of that circle that we have. We can see that 90 over 360 is equal to 1 over 4, and so we have a quarter of a full circle. An alternate method to this would have been to find the area using pi r squared and then just divide this area by 4. Part 2 of the question says that a second sector of a circle is drawn with a centre of D this time and a radius of dA, and we can see that this sector overlaps the sector in the previous part to give us this shaded region here, which we're asked to find. This shaded area is going to be the full area of a square minus the area of these two white regions. Each of these white regions is the area of the square minus the area of the sector found in B part 1. The area of this shaded region is going to be the area of a full square minus 2 times the area of the square minus the sectors, which again is the regions that are white in the diagram. So from part A we know that the area of a square is 81 centimeters squared, and from B part 1 we know that the area of the sector is 63.6. So plugging these values into this formula, we can see that the full area will be 81, the area of the square, minus 2 times the area of the square minus the sector. This gives us 81 minus 2 by 17.4. This tells us that the area of these white regions is 17.4. There's 2 of them, so multiplying by 2 we get 34.8. So finally the area of this shaded region is the full square 81 minus the 2 white regions, which are 34.8, which gives an area of 46.2 centimeters squared. The C part of the question tells us that there's a point P on the arc of the sector DAC as shown. We're told that this shaded triangle APC is isosceles and we're asked to find the area of this triangle. So to find the area of a triangle we need 2 things. We need a base and we need a perpendicular height. The base is going to be the diagonal of the square and the height is going to be the radius dp minus half the diagonal of the square. So how do you find the diagonal of the square? Well, we can see that ABC forms a right angle triangle. We're looking for the diagonal of the square, which is A to C. And we know that A to B and B to C are both measurements of 9. Pythagoras Theorem, which is in our table, says that the hypotenuse squared will be equal to the sum of the squares of the other 2 sides. So AC squared will be equal to 9 squared plus 9 squared. So AC squared is 81 plus 81. AC squared is equal to 162. And AC is the square root of 162, which is 12.73. So we can add this to our diagram, and this is going to be the base of our triangle. So to find the perpendicular height of the triangle, the distance from P to the line AC, we can see that that's going to be the radius of the sector, D to P, which is 9, minus half the diagonal of a square, which is half of 12.73. And this gives us a perpendicular height of 2.64. So finally, the area of the triangle is going to be half the base by the height, which is equal to half of 12.73 times 2.64. So the area of the triangle is equal to 16.8 centimeters squared.